Container security. What is there to talk about here? Well, as developers, when we start containerize our applications, there are new concerns we have to take into account and things that if we're not watching out for, we can get in trouble with. First of all, there's an increased scope of responsibility when you start containerizing your application. If you're like me and you've been coding for a while, containers might be new to you. And when you start containerizing your apps, you start realizing there are a whole new scope of responsibilities I'm looking at. I'm looking at things like operating system packages, file permissions, things I already knew about, but usually were handled for me by an operations team or security teams or network analysts for firewalls, things like that. Now, these things sit right alongside my code in Docker files and other manifests that even if I have other teams helping me write those, if I make an edit to one, often right next to my code in my repository, I could be opening us up to a security vulnerability that I might not even be aware of. And to be honest, most of us don't have a level of expertise needed to understand what's the difference between base image A and B, distributions, packages, all these kinds of things. And we can make mistakes that we didn't even know we're making. Finally, we moved to this DevOps agile iterative development framework over the last decade and a half. And we don't want to introduce any kind of process or tooling security-wise that's going to slow that down because business is not going to be happy with us. The whole idea was faster time to market. We don't want to introduce tools and practices that slow that pipeline down unnecessarily. So let's step back and take a look at what we might be talking about when I'm writing a service or an application of some kind. And what is it that contains? Well, obviously, we have our source code. And that could be Python or Java or whatever. And we know we need to write secure code. That's just something that is part of our job as being a skilled software developer. We also have things like packages that we're bringing in, whether it be Python from PyPy or through Maven or Gradle for Java with libraries and their transitive dependencies. We know that we need to be making sure we're pulling in vetted, good, secure libraries. And we have tools, and Snyk provides tools to help you with these things. But now we have things like the Docker file, which is requiring me to understand, well, like in this example, what is Python 3? Is it 3 dot something? Is it 3? What distribution is it on? Do I need to care about those things? What is apt-get or APK or yum? And these things like stress-ng in this example. I don't know, does my app need that? What is it for? These kinds of concerns are often new to developers new to containerization. And finally, you've got your IAC code, like your Terraform templates or CloudFormation, or if you're in container world, you're often dealing with Kubernetes, which is an API that changes 3 times a year. And making sure that the app is running is enough to make you hyperventilate. Making sure it's secure, it can be a task that is just daunting. So enough slides. Let's get into this. Let's talk about an application and what can happen if you're not paying attention to this. Let's set the stage. We have an application that is a legacy Java JEE application. That's our moneymaker. It's in maintenance mode. We're not doing a lot other than just simple bug fixes to it. And years ago, we did a lift and shift, put it into a container, running it on Kubernetes to take advantage of that, the fabric there. And this is our Docker file that we're using to create that. We have a Maven build happening in the first stage. This is a multi-stage Docker file. If you're not familiar, you have 2 stages. We're doing all our build here where our source code's coming in and that's all going. And then we have the final stage where we're taking the official Tomcat image from the Apache Tomcat project. And on top of that, we're adding a few configurations and then the artifacts from the first stage. You see copy from build, putting that together and just running it on top of Tomcat. I have this running right now. I'm just loading it locally for simplicity's sake and with Docker Compose as if I'm a developer working on this. But imagine this is deployed out somewhere on our production cluster. So here's our app. It is the big moneymaker, the to-do list application. It's working fine. I'm not going to go through it right now because that's not really the point of this conversation. I'm going to shift now to a black hat style, a hacker, and what they might be looking for to try to exploit my application. So let's say I am a Java-centric hacker. I am familiar with the JVM and some of the packages, and I'm perusing over coffee in the morning the Apache Tomcat vulnerability fixes. This page is all the Tomcat 8 series, and all of these changes are fixes for security. And in here, I'm not going to keep scrolling, I'm just going to pop over here. I happen to see, oh, there was a remote code execution exploit that was fixed in Tomcat 8.5.23 a few years ago. And that means that anyone that might still be running an old version prior to that possibly could exploit that. The CVE has a bunch of information. This is Snyk's vulnerability database version of the CVE feed with a bunch of extra stuff that our security analysts add to it. And I could read through this and I could start studying how this vulnerability works. But one of the nice things about older vulnerabilities is there's usually a lot of stuff, including proof of concepts. And sure enough, in these exploit DB links, there's an exploit database entry with a Python script that helps me with figure out if I'm vulnerable. It has a proof of concept. So here I am at my shell, and I have put an alias in called check. Imagine that in real world, I might have some kind of like war dialing kind of a thing where I'm going through all the different endpoints in the IP ranges, looking for vulnerable web servers. Here, I'm just hitting my local for this demo, but I'm running that Python script we just saw, and it reached out to my endpoint, and it sees, hey, this looks like it's vulnerable. In fact, it has put a proof of concept injected into my website. So I'm going to come over here, and I'm going to replace. In fact, first I'm going to take a look at the top level and show you. I'm running Apache 8.5.21. You can see that there. But now, if I put in poc.jsp, you see those A's. I guarantee you, moments ago, those were not out there. What has happened is that Python script has injected a JSP into this Tomcat container, and now it's being run. Now, there's a second piece to that POC that's a little more interesting. I'm going to run this PWN, and one of the things I can do with that is change this POC to PWN, and I got a little form here, and I can do things like hostname. That just ran the hostname Linux command in the environment that Tomcat server is running. This is a remote code execution exploit in the wild. That's a very unique named thing, so that tells me I'm some kind of ephemeral environment. Let's look at my environment. These are the environment variables for the Tomcat process. And I can see things like the word Docker coming up in a couple times, so that tells me I'm probably in a Docker container. If this were running on Kubernetes, I would likely see things like Kubernetes API, where I could see the internal IP address from the pod's point of view of the API server and service ports and things like that. Let's see, who am I? I'm root. That's handy. That's not uncommon. A lot of open source, in fact, most base images from open source projects default to root because they expect you to extend that image and be doing things to it. But they also will provide you with a non-privileged user to use. But if you don't know to do that, as is happening here, I'm root. So let's see what else I can do. Let's see. Obviously, since I have permissions, I should be able to see things like files in Etsy. There's the hosts file for this machine. Let's see if I can create a file there. Let's touch Etsy foo. Now we'll do lsltr on Etsy. Scroll to the bottom. Sure enough, there's root created a file called foo just now. So I have a writable file system. What else could we do? Well, let's see. Can I curl something? Let's curl google.com. Yes, this tells me two things. I have curl at my disposal in my path. And since I got a 301 redirect, that tells me I did reach out to Google most likely and got that redirect. Something has responded correctly. I can do that. That tells me I have internet access. So at this point, honestly, I'm probably curling down some scripts and using it to either mine crypto on all the CPU cycles I can get out of this container, or expand my exploit and try to get out to other things on here. But part of that could be apt-get update. And sure enough, it looks like it is going after the Debian APT repositories and getting them. Some of this is not coming back because it's not standard out, and this interface doesn't show that. But maybe I want to install Nmap and start poking around now and see what else I can find. So you can see how bad this can get. Even though I'm in a container, I still have access to do a lot of things. So let's stop. Hopefully at this point, whatever company is running this server is getting a ton of intrusion detection alerts from their network monitoring and their process monitoring or whatever else, and that would be good. But wouldn't it be better if we could have headed this off much earlier? So let's go back and pretend we're the developer again. And we've got this image. Say I'm working on a bug fix on here. And as part of that, my unit testing, I'm going to run it locally. So I do a build on it. And if we take a look, Docker image is, I think I called it Java Goof. Sure, up there it is. So one of the things I can do right as I'm working is do a sneak, let me clear my screen, sneak container test Java Goof. And I'm going to also feed it the Docker file since I can. That's extra metadata since I'm the developer on it. I have. Also, just to make this, for this demonstration, to reduce the amount of output, I'm going to tell Sneak, don't include any deep level searches. I don't want a huge output for this demo. So Sneak is going to start analyzing this image. It's looking through all of the packages that are installed here, looking for fingerprints of certain binaries we know about that are possible issues. Now it's built a bill of materials, and it's querying the Sneak vulnerability database, which is constantly being updated by our security analyst teams. And what we got, if I scroll up, is if you've used container scanners before, whether built into registries or other command lines, getting a big spreadsheet or list of CVEs is common. And that's what we have here, is all of these CVEs telling me, hey, here's an integer overflow or wraparound. And if I would update this package, I could, get over that. That's fine, and that's good. But one of the nice things Sneak does is it will also present me with some actionable information that in the image summary. And saying, hey, your base image, 8521, which if you know anything about Java and Tomcat, that's really old, especially in 2023. This is coming to the table with 735 vulnerabilities all by itself that you're just inheriting. 70 are critical and 196 high. That's really bad. And if we were to scroll up, we will find that RCE in this list. Then it's making a recommendation, and it's saying, hey, you could make a minor update to the patch level of this Tomcat base image to the .97. Yes, there's that many, 21 to 97. You can make this minor upgrade, and it'll drop you to 28 vulnerability total with 0 critical and high. That seems like a good idea to me. But even if I'm a junior developer, I don't know anything about base images. May not even be a middleware person. I don't know Tomcat that well. I can take this information and proactively go to my lead or my middleware team or my security analysts or all of them and say, red flag, folks, this looks bad to me. Can we talk about this? And have an educated discussion now about the output I'm seeing here. And, put on my architect hat, yeah, we can't go to 10. It's no better anyway. And we're not ready. These alternatives look great because they have 0 vulns, but they're on the Amazon Corretto, which could be cool, but we're not ready to do a full regression against a whole new JVM. So we're not ready to do that, but we could definitely go to the latest patch version and run our normal regression suites and be pretty satisfied that this is going to work. And that's a good idea. So let's do that. So I'm going to edit my Docker file since it's right here. And let's go down to that 21, and I'm going to change it to 97. And we'll do a build again. All right, build is done. Let's run that Sneak container test again. So it's going to do the same thing. It's going to pull up the new image I just built and build a bill of materials, send that off to Sneak, or start querying Sneak's database based on what's in that bill of materials, and come back with the same kind of output, hopefully shorter. And the summary now says, yes, you're based on .97. There is no other recommendation for a minor update because you're on the latest most secure version of the 8.5 family. And then here's some alternatives again, if you want to go to zeros. But we've now eliminated entire swaths of vulnerabilities. So let's stop my Docker Compose. Imagine, this was happening, in production servers. We've checked in our fix, Argo or whatever has pushed a new version out, and let's restart this. And let's just see now, if I had been working on this bug and found this problem and updated, what would it look like from the front end? First of all, that manager screen that showed me the Tomcat, info is not here anymore, because at some point between 21 and 97, Apache realized, we probably shouldn't be putting the management in console by default into an image, because that's something you can add if you want it, but it's not something we want to expose by default. So that's a good sign. Let's make sure the app still works. There we go. There's the to-do list zoomed in, but whatever. Okay, let's try to exploit it again. Go back over here, do the check. Not vulnerable. So if this was a real world scenario and you had a hacker with a script going looking for vulnerable servers for this vulnerability, it would have seen, no, doesn't look like that one's vulnerable, move on. By simply running a container scan that took seconds locally before I even commit my Docker file change, I was able to head off a problem I didn't even know existed. Now, of course, you can plug this in anywhere. We also have the ability to monitor images. So every day we'll let you know if a new vulnerability has come up in an image you haven't even changed. We have the ability to latch into your source control. So for instance, I have the same project in GitHub already being scanned in my Snyk account, and I can see the Docker file here for the application, and has similar information to what we saw originally because I've not checked in this change. Not only can it tell you, you can get an email in the morning when it says, hey, a new vulnerabilities is found and there's a better Docker file, as it says here. I could actually open a fix PR right from our tool. Go in here. And this is true of many different pieces of Snyk. If you've used our source code scanning or our open source scanning, we do the same kind of thing for your Maven or Node.js dependencies, where we can open a pull request for you with new versions of that. Same thing here. It's gonna open a pull request with the from line changed from that old .21 version to the .97 version. So here we are. It has opened this pull request with a nicely formatted table showing what's being fixed by this change. And if I look at the files changed, there we go, it's changing the from line. This can be done automatically for you as well. If you opt in, we will make this pull request happen automatically overnight. Say you wake up in the morning, a new pull request exists with this fix, with that nicely formatted comment. Any of your pull request regression suites would have run at this point, and you can now review this with your team and say, oh, yes, we should take that, even though we didn't even know we had a problem. So that's fine and dandy for vulnerabilities we know about. What about 0 days? What about if you've got a situation where, let's talk about Log4Shell. So as you can see from my Christmas trees, I'm recording this in December. It is 2023 as I record this. 2 years ago, right around this time, we were all dealing with Log4Shell. And it wasn't technically a 0 day because we got a CVE pretty fast, but after it was announced, but it was so huge and so prolific and so easy to exploit. It was effectively like one. It was so, people were panicking, trying to figure out, what do I need to fix? What is vulnerable across my entire enterprise of hundreds of applications? What you can do for that kind of a thing is practice defense in depth. Make your applications hardened against attack. So if they are exploited, or the libraries under them, as Log4Shell, that the hacker has a hard time doing anything with it, that it's not an easy target. The first line of defense when you're talking about containers and orchestrators and things would be the image itself. As you're building this image, you want to make sure that what's in that image is minimal. The footprint is tiny. You saw that I had curl, for instance. Why does my to-do list application need curl? It doesn't. So don't have that in there. And one of the reasons is because I'm using the default Tomcat image tag. I'm not using a slim image or one of the other types of smaller images. Do I need curl? If my app does, well, okay, but maybe you should look at refactoring that app to use a actual Java web calls instead of shelling out to curl to do it. Just take a look at that, because anything you have on that file system, if I do get a remote code execution exploit, I've got it at my disposal to use. I don't have to work. I can live off the land, as the pen testers will say. So reduce that thing. Don't give hackers tools to expand their exploits with. Understand how layers work. You can't just RM curl in one layer and expect it to be gone, because if somebody accidentally were to bind mount in the root file into your container, I can still get at it through the layers, because it'll still be in those layers. Take a look at different build strategies. We're using multi-stage build, which is a strategy that we could be doing better by using slimmer images and making that final image be tighter. But there are other tools, alternative tools. A lot of Java shops will use Jib, which is an open source project that will build containers without the need for Docker or any container runtime at build time. It builds OCI compliant images right from Java, starting from a well-known base image that you provide, and that you, by using other tools like that, or Go if you're a Go development shop, things like that, you're taking advantage of expertise from the open source community and how to build images, and not just writing raw Docker files to do it. They're great tools. Take a look at those. There's other things you can look at, but look at different build strategies. Plenty of blogs out there on that kind of topic. And the secure supply chain, I mean, there's entire conferences literally dedicated to the secure supply chain. What I'm talking about here is just knowing where your images are coming from. When you deploy an image, it should always be coming from an auditable system. It should be a CI server, CD server, whatever, that has audits around it so you know where it came from. It should be signing those images. It should never be Eric's laptop where I type Docker build, Docker push. That is only good for my sandbox environment, maybe. Nothing I build locally should ever have gone to a QA server, a production server, anything like that, because you can't audit really what I've done. Not easily. Plus, the base images you're using, make sure they're coming from a known good place as well. You really should have your own managed registries for any base images you're using where you've vetted them, whether it be your personal registry or a registry you're paying for another company to manage that for you, whether it's Docker Hub Pro tiers, or you could be using ChainGuard images, whatever. Make sure you're using some kind of managed registry so that you know where those images are coming from. After you have your images sorted, the next thing is runtime defenses. You saw that I was running as root. Most applications, especially business applications, do not need to do this. It's just the default. Tomcat has a nobody user I could be using. Node.js base images have a node user I could be using. Drop your privilege down. You can do that in the Docker file with a user line. You can do it in your deployments with the user arguments. We'll talk about Kubernetes in a minute. But make sure you're not running as root at runtime, because it is elevated. And even though you're contained, quote unquote, I can do more with it than I could otherwise. Now, there are user namespace things you can use for running container runtime engines. These are new and aren't highly adopted yet. They will protect you a bit from this, but that's out of scope for what we're talking about. And honestly, most places aren't that mature yet in using them. Privileges. So privilege containers obviously don't do that. That is giving you root access to hosts devices. And that's luckily by default, that's turned off. But one thing you might not be thinking about is privilege escalation. That is, if you can get a binary on a file system that has the SUID bit set, like sudo, if I can get at that, I can elevate my privileges. And there are settings, we'll talk about it in the Kubernetes section in a second, that are not defaulted to stop that. And you should not allow that. Linux capabilities, these are system calls that your application can make to do small, more finite privileged behaviors. Ping used to need this to be able to do ICMP packets on the network. Unless your application is doing something funky with the network stack or other aspects of Linux, you probably don't need any of these for a business application. So I would drop all Linux capabilities if you can and run your app that way. There are blogs and all sorts of articles on how to determine what you need if you do need them. And then we have read-only root file system. You saw that I was able to edit a file in the etc folder. That tells me that I had a read-write file system. So when a container engine like Docker starts a container up, the layers from the image are all read-only, and then it adds a read-write layer that they use copy on write to make mutations in. By having that, I'm able to bring my own scripts in. I'm able to change properties in your application. I'm able to cover my tracks by deleting logs, possibly, if you're dropping them in there. I can modify your binaries. I can put in my own jar file, for instance, and do whatever I want. Read-only file systems it tells the runtime engine, don't put that read-write layer there, and becomes an immutable container. Not counting any volumes you're mounting on your own, which is you need to keep track of yourself. It's not a silver bullet, but it does make life a lot harder for me. If I wanted to start, crypto mining and I had a script I was going to bring down to do that, it would be harder if this was set, and I might just go look for an easier target. And then again, deploy from known sources, same kind of supply chain related stuff. Don't be deploying from random public internet registries. You need to have some control over what you're deploying and where they're coming from. Now, if you're running containers in production, you most likely nowadays are running that on Kubernetes. And if you're doing that, make sure that any credentials that you have you're using secrets for them. Now, this could be Kubernetes secrets, which are fine, but it also could be things like Vault or CyberArk, or RSA has solutions for this. VMware has solutions for this. Use some kind of secret store for that stuff. Do not put secrets in a config map. Do not put them in an image. That's horrible. Don't put them on bind-mounted files, property files, things like that. They need to be in an actual secret store. And if you're using one of those third-party tools already for your applications, continue to use it. They are great tools, and if you have expertise in-house for those, that's the best thing to do. If you're using Kubernetes for secrets, make sure that, especially if you're on like an on-prem Kubernetes where your admins built it themselves with kubeadm, that they are encrypting those secrets at rest. Because otherwise, if anyone gets access to your etcd database, they will be able to see those secrets because they are just base 64 encoded. They're not encrypted by default. They can be, and they should be. If you're using a managed Kubernetes, usually the default is set at cluster creation time to encrypt secrets. Make sure that's true, but that's a good reason to use managed Kubernetes. Role-based access control, RBAC. Use it. There's not a lot to say there. You need to restrict what things you have access to in Kubernetes. Service accounts need to only be accessing the things they need to run the apps. They don't need blankets. Make sure you're locking down the default namespace, things like that. Make sure RBAC is being implemented well. Security context. So these are the APIs on the pods and containers that implement a lot of the things we talked about in the runtime slide. Things like the privileged escalation. That by default is not set to false, and it needs to be. You need to set that to false to make sure that I don't get an image out there that has a sudo command in it, and then now I'm root in a container in your pod if I somehow got access to start containers or pods in there. So there's other things in there like running as non-roots, all sorts of security things in there. We actually have a blog. There'll be a link in the video description talking about security context and the 10 most important things you probably should be paying attention to that my colleague and I wrote a while ago. Network policies, one of my favorites because most developers shy away from this. And I did too until I learned it. It's very easy, actually. Network policy, it is firewalling, but it's not like network perimeter firewalling that you have to open tickets for and things. This is simply a definition of what can talk to each other. And I'm a fan of saying nothing, zero trust on the network. No pod can talk to each other except for DNS. You got to have that. But except for the allow list I specify. So if I've got this application may have a service and a database behind it. Front end can talk to back end this direction on TCP port 80, and then it can talk to MySQL on its port from the back end to the database, but nothing else can talk. That way, if I were to exploit the front end of one of the nodes or one of the pods, I would have a hard time snooping around and finding other things on the network to break into or going back and forth between frontier nodes. So network policy is your friend. I'll put another link down in the description for some good recipes on how to write good network policies. And finally, all of these things need to be enforced. It's great to do these things, but it's better if you can make sure they're being done. And admission controllers like OPA's Gatekeeper, Kyverno, and even the built-in pod security admission, PSA, sets to restricted level, will stop a lot of bad practice in these areas from ever making it into your cluster. So an admission controller is at the front door, basically, and says, hey, what you're asking me to deploy is out of policy based on what you've written in your policy as code. And I'm not going to let you do that. You can also do mutations and things like that. But key takeaways here. Your feedback loop needs to be fast. And you need to use a tool like Snyk that allows you to scan these containers locally and in your CI and wherever else in your pipeline that you want to have checks. But it also needs to give you, to empower the developers with proactive information. It can't just be a spreadsheet of CVEs that the security team bats them over the head with a week after they've committed their code because they just did their audit. It needs to be something that says, hey, here's the problem, and here, if there is a way to fix it now, here's how to fix it, including base image recommendations. And this is true of not just containers. If you go into your source code, our Snyk code tool will let you know, hey, that code right there is unsafe. Here's why. Maybe it's you're not sanitizing inputs or something. Here's what can happen if you don't do that. Here's possibly, we have links to training sessions about that kind of stuff, as well as examples in the open source community of people who have fixed it. Snyk code's pretty amazing. Kind of out of scope for this video, but take a look at it. And then finally, practice defense in depth. For all the things that a tool can't catch because it doesn't exist yet, if you're practicing defense in depth, you will be in a much better posture to deal with it if it happens to you. So, for instance, Log4Shell. If you had network policy in place to block the JVM from making calls to bogus LDAP servers, Log4Shell goes from a remote code execution exploit to maybe a denial of service if they hammer you with those requests and you run out of threads. Not great, but still a lot better than an RCE. So, that all being said, head over to snyk.io where you can take a look at all of our tools. It's all free. You can use all of the stuff for free for developer use. We have a suite of tools you can take a look at. Containers is just one of them. Like I said, we have a blog about security context. Take a look down in the bottom. I'll put the link down there. Thanks for taking the time to watch this, and have a great rest of your day.